Hello, Reuters, Customer Liaison, Alex speaking. Hello.
Screen has just gone completely blank. Keyboard doesn't seem to be doing an awful lot. There's nothing I can do. I'll try to switch it off and back on again, but I mean, it looks okay. It's just doing nothing at the moment.
Okay, can I take your name, please? Okay, your job reference number is 66745. And we'll send someone around as soon as possible. Okay, thank you. Bye-bye.
Thanks a lot. I've got that one. I'm on my way.
Yeah.
Excuse me, I'm looking for Mr. Martin Knudsen.
Yeah, that's me. Are you Reuters?
Indeed.
Yeah, I did.
All right.
Yes, please.
Problems on this one is the actual screen. You can see it's completely blank.
You're on prison,
Yeah,
eh?
okay.
Yeah, I can't get anything at all out of the keyboard.
Okay.
So,
I've got a good idea what it is. Should be up in a few minutes.
Oh, I love it.
Okay.
Okay, yeah, cheers.
Just get on the phone and make sure.
Have we caused another fault? Was it ESD? An electrostatic discharge, commonly known as ESD, occurs when an accumulated electrical charge is dissipated. Static can be generated at any time, in almost any location. Many integrated circuits used in Reuters systems are easily damaged by electrostatic discharge. Electrostatic discharge can, if used properly, be a blessing. Take the example of electrostatic photocopiers. Many companies have prospered by harnessing static, but to us it's a hazard with a potential that could cripple or kill Reuters systems, boards, or components. For the next 10 minutes, let's look at the problem of static electricity, how it's generated, the effect it can have, and how this can be overcome. First, let's consider some basic facts. We're all familiar with some everyday effects of static. Combing your hair, touching a metal object, such as a filing cabinet or a metal door handle after walking across a carpeted floor, and of course, lightning. But how is it generated? Well, first, all materials have different natural electrical characteristics for charge, carrying a positive or negative potential or valency. The farther apart materials are on this list, the more likely they are to generate a static charge if rubbed together. This is because of the charge potential, which is predetermined by the atomic structure of the material. Static electricity is generated when two objects come together and then separate. For example, your shoe and the carpet. One object acquires an excess of electrons, while the other is partially depleted. With a good conductor, this charge will drain rapidly, but a bad conductor may hold its charge for hours or even days. Please don't be misguided into believing that the problem only occurs in carpeted areas. Static buildup is just as susceptible in tiled areas. There are a number of factors that affect the buildup rate of a static charge, and in particular, humidity plays a large part. Today, our customers demand ultra-reliable services, which leads us to explore every avenue of improvement. We cannot afford to let our clients down. From industry data, we know that equipment faults can be reduced by better ES procedures.
Yeah, in 1986, I worked for a British computer supplier, and we were advised by the American parent company that we should introduce anti-static precautions. This was simply because the year before, the American company had introduced anti-static precautions, which cost them about $1 million to introduce, but it had saved them $12 million in spares consumption costs.
Today's technology in particular demands state-of-the-art handling. Now let's look at how it's done. We'll go back to our site engineer.
I've been supplied with an anti-static kit, which consists of a mat, 2 straps, a 1 meg ohm resistor for my protection, and a wrist strap. Connect the clip on the other strap to the earthing point on the rack.
He's just walked across the carpet in this air-conditioned office and has possibly generated 2,000 or more volts of static charge. The fault log means he's got to change the board in the controller. To do this, the engineer is creating a safe working environment. The wrist strap is used to ground any charge he is carrying. The strap is clipped directly to the work mat. The strap and mat are then grounded to the chassis of the unit, providing there's a suitable anchor point or metal-to-metal clip point, and providing that the chassis is also grounded. The few moments it takes to do this ensures that an electrically neutral work environment has been created. Remember from your customer training, it looks professional, it is professional, and you gain customer respect. The approach to ESD is just part of the picture. We've seen what to do in the field, but what about elsewhere? We know manufacturers and suppliers go to great lengths to ensure that equipment leaving their premises is in good health. And to maintain this state, everyone has to take care, whether in materials handling, stores, design, development and testing, transport, training, project groups, central systems, workshops, installation, field service, sales, marketing. In fact, anyone who comes into contact with company products during all phases of preparation must take the necessary precautions. Sarah, is there any sort of pattern to the calls you take from clients?
Well, it's difficult to say exactly, but it's surprising how often some clients ring in with intermittent faults.
Yes, that could be caused by a static damage component or even poor static control in the client's office.
Oh, I was talking to one of the engineers the other day, and I sort of was asking him why he was wearing one of those straps. And I sort of said, you know, was it because, you know, so he didn't electrocute himself? And he said, well, no, actually it was so he didn't actually electrocute the board.
I used to work for a large manufacturer of semiconductors, and on the production line we used to put the integrated circuits into a large drum. The drum would vibrate the devices onto a conveyor belt for testing. When the static boys checked the voltage level being generated on the drum, they found it was 1,000 volts. It made a hell of a difference to the pass rate in test, and they stopped shaking them about.
Over the years, a multitude of myths have built up around the field of static control. Let's take a few examples.
Touching a chassis is enough to ground an engineer.
Wrong. Yes, it will discharge him, but the moment he moves, the charge will build up again.
Once the chip's on a board, it's safe.
Wrong.
Only boards with CMOS devices need protection.
Wrong.
Contact is the only way devices can be damaged.
Wrong again.
PC boards that test out good after improper handling, they're okay. There's nothing wrong with them.
Wrong.
Pink poly bags provide complete protection.
Wrong again.
Surely only electronic equipment in carpeted areas needs protection.
Yes, I know. Wrong. Well, we've already discussed this one.
Yeah, anti-static sprays, wipes, waxes, they provide complete protection.
Wrong. No. These products rely on atmospheric moisture to be effective.
By keeping the humidity high, you will eliminate static problems.
Wrong again.
Come on, let's be realistic. Engineers are not going to wear these static control straps or follow the standard precautions.
Wrong. We must agree the benefits are too great to ignore.
More and more now, you'll see special handling areas designated by these yellow and black triangular signs, such as in stores, central systems, workshops, and so on. Don't ignore them. You could be inflicting unseen damage on a colleague's hard labors. Just look at these electron microscope pictures of damaged chips. Would you work well with holes in you like that? Stop. Think. Keep styrene cups away. Keep sellotape away. Keep plastics away. Keep boards in correct packaging. Keep checking the integrity of your earthing strap. And most important, keep caring.
We're in business.
In Chicago, Rich have an established anti-static procedure. They've produced this invaluable little booklet, which is now readily available from Rich in Chicago under this part number. Portable anti-static workstations are available from stores. And a terminal operations notice has been issued which gives extensive instruction on static control. I hope you've found this program interesting and a useful introduction to start thinking about treatment of integrated circuits. Static control is our target. Success is your responsibility. The results will be significant.